In this video, we're going to discuss facilities of the object-oriented programming language, which typically can be used to construct classes. So our presentation is called Anatomy of a Class. So what we're going to quickly view here is the name of the class, of course, is required part when you declare it, the program comments that can be present, data attributes, constructors, accessor operations, and also operations designated as public and private, which we already know correspond to public interface and private implementation. So concepts really do not exist in isolation. So when objects are instantiated, they interact with other objects. Objects may contain other objects, or they can inherit from other objects. So there could be different types of relationships between the objects. So first, let's discuss the class name. Class name should reflect that a class represents a concept from an application domain. UML diagram shows classes drawn as rectangles. We use rectangular shapes to draw our class diagrams of individual classes. So relationships among the classes are drawn as paths connecting class rectangles, basically these lines that we can observe between these classes. And for example, a ticketing system for a theater has a bunch of concepts which are application domain specific, and we can talk about tickets, reservations, subscriptions, seat assignment algorithms, web pages, and so forth and so forth. So the class diagram could be potentially viewed as we have classes which are rectangles, so customer is here, name of the class, so is reservation, so is subscription series, individual reservation, and so forth. The middle part identifies the data attributes and static operations. If you want to display static operations in UML, you can use the underline notation for those. Now, of course, these simple connections are called associations, and we have multiplicity specifiers, and we say for one customer, multiple reservations are possible. Now, reservation here is displayed, the class reservation here is displayed in italics. Italics means that this is an abstract class. So it means that abstract class may have abstract methods. To be able to implement the rest of the abstract concepts, so reservation is not finalized here in this class. So in order to be able to provide more concrete implementation of the reservation, we derive two classes from here. So subscription series is a kind of reservation, and individual reservation is a kind of reservation in our system. This relationship, of course, is called generalization in UML. Now, for the subscription series and individual reservation, we can have tickets. And the ticket class here is shown as the individual reservation may have 0 or 1, just 0 or 1 ticket associated with this reservation. At the same time, subscription series can have basically 3 to 6 very specific 3 to 6 tickets associated with that subscription reservation. You can see that this UML diagram already telling us a lot of things. Okay, now this constraint shown here specifying is that when the ticket exists, then in case of this ticket, it's possible to have only that ticket associated with individual reservation or subscription series, but not both. This is why we use this exclusive OR key in this constraint, specifying that it's either this or that. Okay, so that's the idea. Now, a show, a theater show here, may have multiple performances, and again we have data attributes and names of these classes. We have the simple association, and here we have multiplicity specifiers 1 and 1 to asterisk, which is 1 to many. Okay, so which means that a show can have multiple performances scheduled obviously for these dates and times of the day. We also have this relationship qualifier that this ticket is associated with specific seat. Okay, so obviously when the ticket is sold, there is association with the seat. So you can see how much and how many very concise, very condensed information is presented in the diagram. And one of the interesting aspects of UML is that you can have a lot of details in these diagrams, and at the same time, if you want to just skim through and just to try to gain general idea what this is, you really don't have to look at any specific data attributes and all of these little details about associations. Just look at the names of classes. Okay, so customer, reservation, show, performance, and then you can focus on specific parts, on more details of this diagram, as opposed to just always try to focus on all little details. So that's the idea of the diagram, and it's a very close relationship to how software is coded as well. Typically, programmers don't focus on 100 different lines of code. Normally, programmers are working on a few lines of code, maybe in 1 or 2 different files if they do some work in parallel, and oftentimes it's just one file, and always focusing almost on a single line, on single computation or expression or a loop. So it's very focused attention. And so this is kind of very similar to the idea of how you can try to interpret the class diagram and other UML diagrams. You can try to look at it at a high level, or you can try to dig really as much as possible into all sorts of detail and try to understand all sorts of intricate information that can be interpreted here specific to relationship between classes.